Alright, in this section here we're going to be talking about equations. So an equation is a statement where two algebraic expressions are equal. Here's an example. So let's say, for example, we've got 3x and we're going to set it equal to 2x plus 1. So this is an equation. We have, this is an expression, 3x is an expression, and 2x plus 1 is an expression, and we set both of our expressions equal to each other and we get an equation. And the idea here is we want to find all the values of x in which the statement is true. In other words, what can we plug in for x on this side over here, and we plug in the same number over on the right hand side, and then both sides are going to be equal. Like, for example, we got 6 would be equal to 6. So we could possibly have one solution. We're going to look at all our possibilities here. You could have one solution, or you might have many solutions. Okay, so we could have many solutions. There may possibly be an infinite number of solutions also. So an equation that is true for every real number in the domain of the variable, it is known as an identity. Here's an example. If I had 2x plus 2 is equal to Okay, in this particular case here, this is going to be true for every real number in the domain. That is all the numbers that we can plug in for x here. So every real number that we plug in for x, both sides are going to be equal to each other. This is known as an identity. However, this equation up here is known as a conditional equation. We might have one solution, or some solutions, or maybe no solutions at all. So this is known up here as a conditional equation, and this is what we're going to mostly be working examples on, focus on, is conditional equations. Okay, there's a specific type of equation that we're going to work some examples on, and these are what are called linear equations. And if I was to write y is equal to 3x plus 5, oops, or maybe just y is equal to 0, is that a linear equation? Maybe you can answer that later. But so this is a linear equation. The actual standard form of a linear equation, so we'll look at the standard form. The standard form is ax plus b is equal to 0, where a is not equal to 0. Okay, so this is the standard form of a linear equation. And this has exactly one solution, and we can prove that just by solving for x in this problem. So if I wanted to solve for x, I would take this b over to the right hand side, and that gives us negative b, and then I would multiply both sides by 1 over a. Here's the reason why a cannot be equal to 0, for example, and that is because you can't divide by a here. Right? Negative b over a, you can't divide by a. So let's look at some examples. Hey, we're going to work some examples of how to find the solutions to linear equations. So let's just get started here. So let's say that, for example, we have 2x plus 1 is equal to 5, and we want to find all the solutions that make this a true statement. So what I'm going to do here is I'm going to take this 1 and I'm going to subtract, I'm going to get rid of the 1 here, and I'm going to subtract 1 from both sides. So we have 2x plus 1 minus 1 is equal to 5 minus 1. And 1 minus 1 is 0, so we're left with 2x is equal to 5 minus 1 is 4. Now we want to get rid of this coefficient here, so I'm going to multiply it by a half. And a half times 2 is 1. And so we're left with x is equal to, and then we have 4 times a half is just 2. Right? So our solution is x is equal to 2. So we started with an equation and we basically ended with another equation. But it turns out that this is also a solution, x is equal to 2. When we plug 2 into this up here, and we'll go ahead and do that just to demonstrate that both sides are equal. And so 2 times 2 is 4, and 4 plus 1 is 5. Alright, let's work another example. Okay, let's see here. How about if we had 7 minus 2x is equal to 10. Alright, so we want to solve for x here. I want to find the solution that makes this a true statement, and that is what we're going to do here. I'm going to go ahead and we got a couple different ways of doing this. Because I'll have a negative here, or there's a minus sign, I'm going to go ahead and take this guy over to this side. And so by doing that, I'm going to go plus 2x. 10 plus 2x. So as you can see, we have a minus 2x and a plus 2x, so that's going to be 0, right? So we got 7 is equal to 10 plus 2x. Now what I'm going to go ahead and do is I'm going to subtract 10 from both sides because we need to get this 10 away. You know, it's kind of like what's going on here. It seems like we hadn't really gone anywhere, but it's because of this minus sign. I'm going to go ahead and subtract 10 from both sides. So I'm going to kind of assume that you haven't done this before. And a minus 10. So as you can see now, we have a minus 10 and a plus 10, so that's 0. And so we're left with 2x. We have a negative 10 plus 7, and that's going to give us a negative 3. Now what we want to do is want to multiply both sides by a half. I'm going to put a parentheses around that right there because of this negative. And so a half times 2 is just 1, and 1 times x is just x. And so then we end up with negative 3 over 2. So that's going to be our solution. And if we were to plug in negative 3 halves into this up here, we should get 10 on this side. And I'm just going to kind of inspect this real quick. Plugging negative 3 halves in right here, the 2's cancel out, so you have negative plus 3, that would be a positive 3, and 7 is 10. Okay. We're going to go on and work lots more examples. Okay, let's look at this linear equation here. This time our unknown is going to be defined as t. Okay, so t is our unknown variable that we're going to be solving for. So we don't have to use x every time. We can use anything we want. Alright, so what I'm going to do here is I'm going to go ahead and distribute this 2 across, and then I'm going to distribute the 3 across, and then we're going to collect like terms. So 2 times 13 is 26t minus, and 2 times 15 is 30 plus 3 times t is 3t minus, and 3 times 19 is going to be 57. So now what we want to do is collect all our like terms up. So we have 26t and 3t, so those are two our like terms, and that's going to give us 29t. And then we have this minus 30 here and minus 57, so we're going to end up getting a negative, and that should be 87 if all is correct. Now what we want to do is go ahead and add 87 to both sides so we can get rid of this minus 87. So I have a minus 87. We're going to add 87 to both sides. So I'm not going to rewrite that 0. And then we have 29t. So that's going to give us, that's going to cancel out to be 0. And then we have 29t is equal to 87. And then we're going to multiply both sides by 1 over 29. Over 29, and so we end up with t being equal to 87 over 29, and of course we can reduce all of this down, and I do believe that 29 goes into 87 3 times. So t is equal to 3. So what I want to do here is I'm going to go ahead and show that this is true by taking this 3 and plugging it back in up here into our equation. Okay, so in the process I did some erasing here and I ended up, okay, erasing part of the problem. Alright, so what we want to do here is I want to take this 3 and plug it in for t. So 2 times 13 times 3 minus 15 plus 3 times 3 minus 19. And this is so we can check our work and make sure we did everything correct. So what you want to do here is you just want to go through and do the arithmetic. 13 times 3 minus 15, get that number, multiply it by 2, and so forth. And I'm almost positive that this is going to all equal 0 over here on this side. Because this is a 0 over on the right hand side, and that means that this side here is going to have to equal to 0. So I'll let you test that out. Okay, we're looking at linear equations and how to solve for them. So the best way to do that is just for me to work a bunch of examples. Okay, so what we've got here is we've got some brackets over here, and the reason I do that is sometimes too many parentheses gets confusing, and so I may throw in some brackets, but it does just pretend this is like a this is an open parentheses and a closed parentheses. So let's see if this equation has a solution. So what I'm going to do here is I'm going to go ahead and distribute this 6 across first, and so we end up with 6x minus, and we're going to have a 6 here, so we have 2x plus 3. And now that I've distributed the 6 across, we can drop these brackets. Except we want to go ahead and close this in here. So we have 8 minus 5x. Now what I'm going to do is go ahead and distribute the 6 across. So rewriting this 6x minus, so 6 times 2x is 12x. Now because we have a minus out here, I'm going to go ahead and distribute this because pretend this is like a negative 6. So this is like a negative 6 times 2x is minus 12x, and then just go ahead and distribute it across, and so we have a minus here, and 6 times 3 is 18. Alright, now what we want to do is collect our like terms up. So we have a 6x minus 12x, and 6 minus 12, well, that would be a negative 6. So, and that's really all the like terms we have on the left hand side. Okay, now what I'm going to do is I'm going to go ahead, and because we have a minus 6 here and a minus 5 here, this is smaller than the minus 5, and I'm going to go ahead and take this over to the right hand side, and I'm going to take this 8 over to the left, and I'm going to do this all at one time here. So in other words, what we're going to be doing here is we're going to be adding a 6x to both sides, and of course if I have a positive 8 here, I need to subtract 8. So hopefully you can hang in there, keep up with me. So I have a 6x and a minus 6x, so that's going to go away. Right, so that's 0. And then we have a minus 8 and a minus 18. I'll just rewrite that. And what's going on over here? Well, we had this positive 8 and a minus 8, and so that's going to go away. And we have a negative 5x plus 6x. Now I'm going to go ahead and simplify this down while I'm here. So this just becomes, pretend this is like a 6 minus 5, which is 1. Right, so this just becomes x here. Negative 5x plus 6x is just 1x. And now we can just go ahead and finish this up. We have a negative 18 minus 18, and that'll give us a negative 26. Now remember that the way to check this, right, you want to take this negative 26 and plug it into where x is located, right? Plug in the minus 26, and then we should get the left hand side should be equal to the right hand side. We want to make sure we plug in that minus 26 over here and then do the arithmetic. Okay, so let's try to find the solutions to this equation here if it has any. So what I'm going to do first is I'm going to distribute this 8 across. So we have 8x, 8 times 2 is 16. Then I'm going to distribute this minus 3 across, so we have minus 6x, right? 3 times 2 is 6, and then minus 3 times 1 is just minus 3. And I'm going to go ahead and distribute this across over here also. Okay, now what I want to do is collect my like terms up. 8x and minus 6x are like terms, and so 8 minus 6 is 2, so I'm left with 2x, and then 16 minus 3 is negative 13, or I'm sorry, positive 13, whoops, is equal to 2x plus 10. Now take notice that we have a 2x over on the left hand side and a 2x on the right hand side, and what's going to end up happening is if I were to subtract 2x out on both sides, we'd end up with 13 is equal to 10, and we know that's false. So this guy here has absolutely no solution, so no solution. Alright, let's look at another one. We have a half x plus a half equals x. So what I'm going to do is I'm going to multiply it by 2 all the way across. So multiplying this side by 2 and this side over here also by 2. So 2 times a half is 1. So we're left with x plus, and 2 times a half is 1. And then we just have 2x. So now what I'm going to do is I'm going to subtract 1 from both sides. And I would normally write this out over here to the right of that, but I just put it under there. So a positive 1 and a minus 1 is 0. So we're just left with x is equal to 2x minus 1. I probably should have done this a different way. Wasn't paying attention, but that's okay. It's all going to work out in the end. I'm going to go ahead and take this 2x over here to this side, and that means that I'm going to subtract 2x from both sides. Yeah, there's always more than one way to work a problem out. But negative 2x, positive 2x is negative x, and then we're just left with a negative 1. Now what I want to do here is to get rid of this minus sign, or this negative sign, I'm going to multiply both sides by negative 1. And as you can see here, I end up with x is equal to 1. So that's going to be our solution. X is 1. Alright, let's look at this one here. Hopefully I've got enough time. Minus x over 2 is equal to 3. So I'm going to get rid of this fraction. I'm going to multiply both sides by 5. And so we end up with x minus 5 halves x is equal to 15. And then I'm going to multiply both sides by 2 all the way across. So we end up with, and I'm going to skip a step here, hopefully you can keep up. 2 times 15 is 30. So now we have 2x minus 5x, that's a negative 3x, equals 30. And then I'm going to multiply both sides by a negative 1/3 to both sides. Alright, and so we end up with x is equal to negative 10, and we can plug that back up into our original and actually test that out, and that should work out.